These are step-by-step fabrication process of part 2, starting from the preparation of the raw material until the final finishing process. First, this is the raw workpiece material that we use to fabricate part 2. Before starting the fabrication process, we use several tools for measuring and marking, including a hacksaw, engineered tri-square, the ruler, center punch, scribe and ball peen hammer. The first step was measuring and marking the raw material according to the required dimensions. The total length was 45 mm with a thickness of 4 mm. Next, the raw material was cut according to the marked dimensions using a hacksaw. After that, a hand grinder fitted with a cutting disc was used to refine the dimensions and remove excess material to achieve a more accurate shape. Then, a hand press drill was used to create the countersink hole and the other required holes. However, it encountered a problem where the drill bit slightly moved away from the marked position. To overcome this issue, we used a center punch to create an indentation at the marking point. This helped the drill bit to stay in position and improve the accuracy of the drilling process. Next, a milling machine was used to remove unwanted parts, clean both surfaces and adjust the thickness according to the required dimensions. After the milling process, thread tapping was performed on both the left and right holes to create internal threads. Next, a hand grinder was used to create rounded edges. However, the handheld grinder has limited stability and control, making it difficult to maintain the correct profile and dimensions. Therefore, a hand file was used after grinding to refine the edges and achieve a smoother surface finish. Finally, the product was filed and refining as the finishing process to remove rough edges and improve the overall quality of part 2. Next, let's move on to the fabrication process of part 1.
To start our project, we carefully calculate all the required dimensions from our engineering drawing to ensure perfect accuracy before cutting any metals. Next, we sat down as a team to plan our workflow, assign tasks and create a clear schedule to keep our project on track. Moving into the workshop, we set up the conventional lathe machine, making sure the chuck and tool posts were securely aligned for safe operation. We then selected the appropriate cutting tools, facing tool and drill bits required for our specific material. Before machining, we thoroughly clean the surface of our raw material to remove any rust or debris that could affect our markings. Just to be absolutely safe, we measured and double-checked the dimension one more time against our blueprint before turning on the machine. We began the machining process by drilling the center pilot holes. During this step, we encountered a challenge. We initially used the wrong cutting tools, which caused minor issue. However, we successfully resolved this by consulting our lecturer and discussing it as a team to choose the right tools. While drilling, we make sure to pit drill frequently to prevent long metal chip from accumulating and clogging the hole, which keep our workspace safe and clean. Before moving on the heavy boring process, we strictly followed safety specification. We wore safety goggles to protect our eyes from flying debris, standard safety boots to protect our feet, and a proper workshop jacket to prevent loose clothing from getting caught in the spinning machinery. Another problem that we faced on the workshop is shortage of the tooling equipment, meaning we had to share the limited available tools bit with other project groups. The solution is to avoid conflicts and rushing. We coordinate with the other teams to take turns using the tools systematically, waiting patiently for them to finish before starting our next operation. Once the pilot hole was ready, we used an internal boring tool to enlarge it. We create a stepped profile with a diameter of 50 mm at the tip of 9 mm, followed by the secondary diameter of 45 mm at the tip of 4 mm. Moreover, during the continuous heavy boring process, the material heat up rapidly, which risks wrapping the metal and damaging the cutting edges of our tools. The solution is we consistently apply coolant directly into the coating zone and pulse between deep cut to allow the temperature to drop, ensuring a smooth surface finish. After finishing the internal cavity, we use a cutting operation to remove the excess material from our stock, achieving our exact target total thickness of 21 mm. Next, we drill 2 holes around the outer circumference of the casing and 2 matching holes inside. These are critical features designed specifically to guide and hold our flexible pumping hose. With all the heavy machining complete, we perform final surface finishing to remove sharp burns and ensure a smooth, professional looks. We then gathered all our machine parts, the center rotor and the roller, carefully assembling them together to form our complete peristaltic pump. Finally, we conducted a performance test on our peristaltic pump to verify that it compresses the tube properly and pump fluid efficiently without any leak.
Hey, it's a good day to be. Anybody if your name is me. Shout it from the rooftop shamelessly. I love her and she loves